All right, so picture this. A bank rolls out this brand spanking new AI to handle auto loans. It's supposed to be totally impartial, just the facts. But something is clearly off. The scales are tipped, and it seems to be favoring one group over another. The big question is, why?
Okay, let's dive into the specifics here. We've got an AI model that's rejecting loan applications from rural folks way more often than from city dwellers. Now, here's the real head scratcher. On paper, their financial situations, credit scores, income, all that stuff are practically identical. So, what is going on here?
To figure this out, we're going to have to do a little detective work. We're going to treat this like a crime scene and line up the four usual suspects when an AI model starts acting up like this.
And here they are, our lineup: measurement bias, confirmation bias, observer bias, and sampling bias. One of these is our culprit. Our job is to investigate each one and see which one fits the crime.
All right, our investigation officially begins. First up for questioning, let's talk about measurement bias. So what is measurement bias? Well, the easiest way to think about it is like using a broken ruler. This kind of bias happens when the information you're collecting is just wrong from the get-go because your tool is busted. Like a credit score system that's got a glitch and always gives people a score that's a little too low. But does that theory fit the facts of our case? Not really. Remember, the problem specifically says that both groups of applicants had similar financials. That's a huge clue. It tells us the data points themselves are probably accurate. The ruler isn't broken, so we can rule this one out.
Okay, one suspect cleared. Let's bring in the next one and see if the evidence holds up. Up next, confirmation bias.
No, this one's really interesting because it's all about human psychology. It's that natural thing we all do. We look for information that proves what we already believe. A classic example is a loan officer who just has a gut feeling that someone's a risky applicant, so they subconsciously look for all the negative stuff in the file to back that feeling up.
But here's the problem with that theory. Our case is about a fully automated AI. There's no human making the final call based on their gut. The bias is coming from the machine itself, not from a person's pre-existing beliefs. So, we can clear this suspect too. 2 down, 2 to go. We're narrowing it down. Let's bring in our third possibility, observer bias.
Observer bias is a bit sneaky. It creeps in way at the beginning, during data collection, long before the AI even sees it. For example, maybe a loan officer just really likes younger applicants, and because of that, they tend to write more positive notes in their files. Well, those biased notes then get fed into the system as if they're objective fact.
But once again, this just doesn't fit the evidence we have. Our case file doesn't mention anything about a human's feelings influencing how the data was recorded. The problem seems to be baked right into the model's logic. So, suspect number 3 is officially off the hook. So, where does that leave us? We've gone through our lineup. Measurement bias? Ruled out. Confirmation bias? Doesn't fit. Observer bias? Nope. Through the process of elimination, that leaves just one suspect standing.
And it's time for the reveal. The culprit behind the bank's skewed AI, the reason all those rural applicants were getting unfairly denied, is sampling bias.
So, what exactly is sampling bias? Well, this is where it all clicks into place. It's not about having wrong data. It's about having a data set that simply doesn't reflect reality. The sample of information the model learned from was fundamentally incomplete.
And here's exactly how it happened. The AI was trained on a mountain of past loan applications. But here's the catch. That mountain was lopsided. It was filled with tons of examples from urban applicants, but had barely any from rural applicants.
As a result, the AI became a genius at understanding urban applicants. It knew their patterns inside and out. But rural applicants, it just hadn't seen enough of them to learn. They looked like an anomaly, an unknown. So the AI played it safe and just said no. The model wasn't being malicious, it was just poorly educated.
And that brings us right back to where we started. Those tilted scales, they were tipped from the very beginning, not because the algorithm was broken, but because the data it was fed was fundamentally unbalanced. Case closed. Sampling bias was the culprit.
Okay, mystery solved. But this is about more than just one hypothetical bank. So why is this so important for all of us to understand? Let's zoom out and get to the big takeaway. This quote really says it all, doesn't it?
An AI model is only as fair as the data it is trained on. It sounds so simple, but this idea is the absolute foundation for building AI that's actually responsible and fair.
And if you take one thing away from this explainer, let it be this. You can have perfectly accurate, flawlessly measured data. But if your sample of that data is skewed, if it doesn't represent the real world, your AI's results will be skewed too. Fairness doesn't start with a fancy algorithm. It starts with the data, which, of course, leaves us with a pretty big question to think about. If the data that an AI learns from is the source of the problem, what other hidden biases are working away in the background of all the automated systems that make decisions about our lives every single day?